I want to show you a couple of neat little tricks and my little shortcuts of doing arithmetic sequences in series. And this right here is an arithmetic sequence. What you should notice is each time your common difference is 7. You're adding 7 each time. And I'll just tell you now, this is 20 terms. So there are 20 terms here in the sequence. It's a pattern. I just kind of kept going and stopped, and then I finished the end out. Now, I have a different rule here. To find the rule, which rules generate terms in the sequence, to find the rule, I use A0 plus DN. It's different than most textbooks. A0 basically is, in my mind, means the term before the first term. So if this is your first term, your A1, what term would be before this? Well, if you added 7 this way, don't you subtract 7 to get this way? So wouldn't this over here be a -4? So you added 7, so you subtract 7. So what happens is A0 is now -4. So if I want my rule, A0 is -4 plus D, which is 7 because you added 7 each time. That's your rule. I just think that's a lot quicker and easier than most textbooks. It's kind of weird. A0 really isn't a term because it's not part of the pattern, but we're thinking what started it off. Now also, if you think about the logic behind this, what this is stating, it's saying that you started at -4 and you're adding 7 in times. So if I want my first term, does that mean I added 7 once? So 7 times 1 is 7, so -4 plus 7 is 3. If I want the third term, doesn't that mean I added 7 3 times, which 7 times 3 is 21? -4 plus 21, isn't that 17? I want the 20th term, same idea. You adding 7 20 times. That's what this whole formula means. You're starting with the 0 term, the term before you started, and you're adding 7 in times. So again, say I wanted the 30th term. All you do is you do -4 plus 7 times 30. And when you plug that in, this becomes 210. So -4 and 210, so the 30th term looks like it's going to be 206. That's just a real cool way to do the rule, or the term generator. Now, this is the formula for the series, to value the series. But a series means you're going to add up these terms. So we're going to add it from 3 to 136, add them all up. That would take a while. Now, where does this formula come from? It's really cool, actually. It's a really cool little shortcut to understand it. What we're doing here, this is the last term, this is the first term, this is the number of terms, and we're halving it. Basically, I want you to see a pattern here, because you can memorize this and plug it all in, great. But I just want to show you where this comes from. If you just take the first term and the last term, add those together. What's 3 plus 136? Well, it looks like 139. Okay, let's take the next one. 10 and 129. What's 10 plus 129? Well, that's also 139. Interesting. What's 17 and 122? Hey, wait, do you guys see a pattern? 139 every single time? Maybe it'll rhyme. That was kind of funny. Alright, anyways, 139 each time. So what happens is every time I add the first and the last, do you see a pattern? So when they're if this is 20 terms, aren't I adding 139 10 times because I'm grouping them in pairs? Wouldn't that be half the number of terms? If this is 20, doesn't half be 10 because we're pairing? So don't you basically half the number of terms and add the front and the back? All arithmetic sequences, when you take the first and the last and you start adding them in, they always add up to the same number. It's just a phenomenon. It's kind of cool. So this number will always be the same when you take and start going in. And the n over 2 basically means you have half the number of terms. That'll always work. It's a cool little pattern. So if we want to do this one, basically the answer to the 20 terms would be 20 divided by 2, the first term, which is 3, plus the last term, which is 136. Now this is going to be kind of big, because this is what, 139, and this is going to be 10. So the sum of the first 10 terms is 1390. That would be a pain to do without a formula, but it's cool to help you remember the formula. And this A0 plus DN just helps you really quickly get the formula. Now, a lot of times we don't give you this right here. We just say, give 20, add up the first 20 terms. So how would I have found 136? Well, I just would have plugged in 20 to this equation. Then I would have this last term. That's sometimes annoying with arithmetic series. You have to kind of get that last term before you can do anything. So hopefully this helps you.